Today we'll go over a few examples of growth and decay word problems. For each of the following problems, we're going to A. Identify the rate and the factor. B. Write a function modeling the situation. C. Identify the y-intercept as one of our key features. Write the equation of the asymptote. And E. Identify the domain and range of the situation. So if we look at our first example, a population of 800 beetles is growing each month at a rate of 5%. Couple key parts here is understanding that we are growing, which is letting us know that this is a growth. It's already telling us the rate, and it tells us what we're starting with, 800 beetles. So A asks to identify the rate and the factor. In this case, our rate is 5%, whereas our factor, which we labeled as B, is equal to 1 plus our rate as a decimal, which would be 1.05. B asks us to write a function modeling the situation. So we want to say that our f of x in this situation is going to equal the start, 800 beetles, the factor, which we already simplified to be 1.05, and this is going to be exponential. It increases by 5% each month. It wants us to identify the y-intercept. Now another thing we need to remember about y-intercept is it is the start of our function, is when our x value is 0. In this case, which would be 0, 800. We started off with 800 beetles. For D, it wants to write the equation of the asymptote. Now we haven't shifted our equation at all, so this is still going to keep our asymptote equation y equals 0. We haven't changed its location. E wants us to identify the domain and range. In this case, our domain is all real numbers. There's nothing that is limiting what our domain can be. If I can write this correctly, I don't need to write the x. We're talking about domain, which is all real numbers. Our range does have limitations. In this case, we know that our range is going to start at 800 and it grows. So 800 is going to be a low value. We know that it can be equal to, and it can increase for this situation infinitely, or for the information that's given infinitely, not for this situation. We know at some point the population is going to plateau off, but for the information that is given, we have 800 is less than or equal to y, or another way of writing it is y is greater than or equal to 800. Problem F is asking us how many beetles are there in 5 months. Since this is counting by each month, we only have to substitute in the value 5 for our x. If we use a calculator to quickly do this, we'll get roughly function of 5 to equal, so in 5 months, 1,021. And I said roughly because we are rounding. Roughly 1,021 beetles. For our second example, we have a new computer that cost $1,500, but depreciates. We need to understand that the word depreciate means to lower in value by 18% each year. So now if we look at our instructions again, it wants us to identify the rate and the factor. So our rate in this situation is 18%. Our factor, I'm going to keep not simplified, just so you can see what it looks like. We are subtracting 0.18. That is 18% as a decimal. B is to write a function modeling the situation. Our function yet again is f of x. It is going to equal our start, which is 1,500, times the factor, which we did not simplify on purpose, being 1 minus 0.18, and all this raised to the power of x. For C, it has to identify the y-intercept, and D is the equation for the asymptote. Y-intercept is simply the starting location, which we know is 1,500. As a location, that means our x value is 0, and we start at 1,500. The y-asymptote, yet again, or not y-asymptote, the asymptote, yet again, is y equals 0, as we did not shift our equation anywhere. We simply multiplied, changing its shape. Last, we need to identify the domain and range of the situation. Now, I think I made a mistake on the last one. Of the situation is the key here. So for this, our domain would not be all real numbers. As we would not have a negative population, we would say that x is any value greater than or equal the starting value of 0. So for the model, which I accidentally did it based off of, it would be all real numbers. For the situation, it is starting at 0 time and increasing as time goes on, which is the same situation for this one. The new computer cost him $1,500. Our time frame would be, oops, if I can get the writing. Domain would be x is still greater than or equal to 0, and depending on when the computer fully loses its values, whenever our domain would stop. We don't have that information, so we leave it as such. Our range is easier to find. We know that it is going to be a max of 1,500 when he first purchased the computer, but it's also going to have a minimum value of $0. It's not going to cost him money to own the computer. Last part is how much is your new computer worth in 3 years? We would take our formula. We're solving for when our x value is 3, which means we're replacing x with 3. And we are rounding again. And if we plug this into a calculator, we would get roughly $827.05.